Alrighty, welcome to the Conner equation part 2. For those of you who had doubts about part 1, was not to your satisfaction, this video will be for you because we're proving the exact same thing. We're trying to prove this formula, but we're doing it in a way that is pretty, how shall we say, undeniable. So the reason why we really, the tricky part about proving this formula is that, okay, I can prove that it works, I could prove using opposite interiors and opposite exteriors, and you could even throw in vertical angles, all that. But if I do it for one quadrant, right, I don't know a mathematical rule that extends it to all the other quadrants, to all the other configurations, especially with angles that are bigger than 180 degrees, all right? Because once you get bigger than 180 degrees, then you're going past this parallel line. So that is why we're gonna go quadrant by quadrant, and we're gonna prove it for each quadrant. We're gonna prove it between all the angle sets. We are going to also prove it, I'll even throw in 90 degrees, right, and 270 degrees, a straight line, vertical straight line, and then 0 and 180 degrees, because those are actually kind of tricky, 0 and 180 degrees. I'll do that last. All right, so first things first, right, we have our line that's parallel, that is the positive x-axis, right? And so we have phi, this angle, this is phi n minus 1. There we go. All right. So we know, because of opposite interiors, that this angle, this is our line parallel. This is very similar stuff to the other video. Line parallel to the positive x-axis, right? And because it's parallel, we can use the rule opposite interiors. The first things first, we're going to add 180 degrees, like so. You see that? Straight line, 180 degrees, okay? Then, we know that this angle is also phi n minus 1. So we're going to add that. What does that get us? That gets us here, right? And I should probably draw, what's the next line? I don't know, there. This will be theta, and this is the interior angle, the raw interior angle. So once you get to the line, this would be like SL, K minus 1, then theta, the interior angle, always connects one side of a polygon to another side. So you always, just whatever theta n is, it could be this, it'd be, there's a bigger angle. You just add it. It could be there. Just add it. It's as simple as that. Now I'm going to do it where phi n minus 1, all right, is 90 degrees. Right there, phi n minus 1. You see that? When it is 90 degrees, obviously I think it's pretty obvious. It's the same exact thing. You start, we always start, very important concept. Good thing I remember to mention it. Remember, we always start at 0 degrees. So 180 degrees, same thing, phi n minus 1, whatever theta is. Let's say it's this. This is a big angle. So I'm saying right now, theta n is that whopping big. It connects the side, right? It connects these are the two sides, right? Phi n minus 1 is this side, is the angle of this side of the polygon, right, relative to the positive x-axis, right? So theta n always connects the side. So 180 degrees, then opposite interior is phi n minus 1, and then theta n, the interior angle that's connecting the two sides. That's for 90 degrees. Very simple. Next, when phi n minus 1 is greater than 90, but less than 180, phi n minus 1. All right, same thing, 180 degrees. We start from 0, 180, right here, phi n minus 1. And a same thing. Let's make it like this polygon. There, that's the next side. That would be theta n. You see, it's the same thing, except instead of the smaller kind of angle, it's the larger one. All right, so same thing, same opposite interiors. It's all good. And I hope also you guys know, of course, when you add all these angles up, it's actually, I don't know if you could see this, 180 degrees plus this big angle plus this big angle, it's going to be greater than 360 degrees in its raw form. But that's fine. A 380 degree angle, that's the same thing as a 20 degree angle, right? It's all about where you end up that's relevant, okay? Remember, I'm going to do 0 and 180 degrees last, because those are so simple, it's kind of complicated. So I'm going to go when phi n minus 1 is greater than 180, but less than 270. Remember, so the positive x-axis, right? So in this case, the side is kind of, instead of going up in various ways, it's going down, right? So, oh no. Oh boy, this can get tricky sometimes, but we will get through it. Phi n minus 1. Now this is a tricky thing maybe for some people. You're used to using the rule opposite interiors, opposite exteriors for when it's like the small, like these angles or these angles in the corresponding angles, right? That it's congruent with. But it also works with big angles, huge angles, right? Angles that are greater than 180 degrees. Why do I know that? I guess the simplest way to explain it is, right, this occupies all three kind of sectors, right? So there's only one sector left. That's this. We could simply use opposite interiors to prove that these are the same. Wait, which means whatever is left, which is phi n minus 1, is also the same. These take the same cut out of 360 degrees. You guys could, another way, these angles are the same, these angles are the same, and then these, and then they add up to the same thing. That's another way to do it. All right, so clearly it works for big angles, all right? So, remember, we are going to start with the zero direction here, right? 180 degrees, straight down. We're adding a lot of big angles together. So 180 degrees, then we add phi n minus 1. That takes us to this side, and then the interior angle, theta n, right? 180 plus phi n minus 1 plus theta n. And that gets us this side, the angle of this side, relative to the positive x-axis. Okay. Now, for 200, I didn't forget, 270 degrees. 270 degrees, come on, it's like the same thing. Phi n minus 1. We start at 0 degrees. Phi n, 180, right? We add 180, phi n minus 1, and then theta n takes us all the way to this side. Now, really big angles. When it's greater than 270 degrees. Same thing. I think you guys can just don't stop watching, all right? But if you really needed to, you probably could. So 180 degrees, phi n minus 1. Man, that theta. Let's make it enormous. Bam. So theta is going to be monstrous. Monstrous theta. Okay. 180 phi n minus 1 takes us to this side, and then you just add the angle that connects the side, and you get to the other side, and that is good. The total, the sum of all those is going to always get you the angle this side is to the positive x-axis. I still have 0 degrees, and I still have 180 degrees. See, this is what I mean by complicated, because 0 and 180 degrees, when phi n minus 1 is 0 or 180 degrees, it is already parallel. It is the positive x-axis. So it's kind of hard to see, because instead of like two parallel lines and then a line that cuts across in some way, they actually all merge into one line. Yeah, that's right. Phi n minus 1, you could imagine it like that, you know. That's also phi n minus 1. Let's start with, we always start, remember? We always start with 0 degrees at 180, okay? Then add phi n minus 1. And what's theta? I don't care. There, that's theta. There's your theta. Theta n. 180 degrees. Phi n minus 1. Theta n. Bam. That side relative to the positive x-axis. Yes, in this configuration, if you actually see this when you're using the counter equation, of course, you, in this case, theta n will always be phi n. That's why phi 1 is always equal to theta 1. It's because we set our first side, SL1, we set it so its interior angle is also phi, the angle relative to the positive x-axis, okay? So if you see that, you can automatically do that. You don't have to go through the whole process. You just realize, oh, that interior angle, that is my phi. That's the phi I need, and you're good to go. Obviously, it's up to your discretion, right? I'm just showing you what will always work. Mathematical proof. And now, when phi n minus 1 is 0 degrees, I'm actually going to draw what it is, 0 degrees, okay? Opposite, basically 0 degrees. Remember, we always start with 180 degrees, then we're going to add 0 degrees. Okay, we've added it. And what is the theta? Theta. I don't know. There's your theta. The interior angle is this. That's the interior angle. It's one of those situations where if this were the interior angle, that's an impossible situation. It's an impossible format for that to be the interior angle. Remember, this is not the interior. This is phi n minus 1. So let me make that clear. Phi n minus 1 equals equals 0 degrees. Okay. So that's just this side relative to the positive x-axis. We add 180 degrees, and then we add 0 degrees. Done. Then we add theta and whatever it is. It's a big angle this time. That's it. It's really that simple.